Have you ever looked up at the night sky and spotted a brilliantly bright star, one that seems to outshine all the others? Chances are, you weren't looking at a star at all, but at a planet, and most likely, that planet was Venus. For thousands of years, humans have been captivated by its radiant glow. The ancient Romans named it after their goddess of love and beauty, a fitting tribute to the celestial jewel of our solar system. It's often called Earth's sister planet because it's similar in size, mass, and composition. But as we've learned over the decades, this sister has a dark side, a story of a world gone terribly, terribly wrong. For a long time, Venus was a complete enigma, shrouded in a thick, impenetrable blanket of clouds. Science fiction writers imagined it as a lush, tropical paradise, a humid world teeming with exotic life, perhaps even dinosaurs roaming vast, swampy jungles. It was a romantic notion, born from the mystery of those clouds. We knew it was closer to the sun than Earth, so a warmer, wetter climate seemed logical. But reality, as it so often does, turned out to be far more extreme and far less hospitable than anyone could have imagined. The dream of a tropical Venus was about to be shattered by the cold, hard facts of space exploration. The race to unveil Venus's secrets began in earnest during the Cold War. The United States and the Soviet Union, locked in a fierce competition for technological and ideological supremacy, turned their sights to our planetary neighbor. This wasn't just about scientific curiosity. It was a display of power. Landing a probe on another planet was a monumental feat, a clear statement of a nation's capabilities. The Soviets, in particular, made Venus their primary target. They launched a series of probes called the Venera program, a relentless assault on the planet's defenses. The early missions were fraught with failure. Probe after probe was lost, either failing on the way or being crushed and cooked by Venus's brutal atmosphere before they could even reach the surface. Imagine the engineers and scientists holding their breath as they lost contact, time and time again. Each failure, however, was a lesson. They learned that the pressure was immense, far greater than the deepest parts of Earth's oceans. They discovered the temperature was hot enough to melt lead. This wasn't a tropical paradise, it was a hellscape. Then, in 1970, a breakthrough. The Soviet Venera 7 probe survived its descent and became the first spacecraft to successfully transmit data from the surface of another planet. It only lasted for 23 minutes before succumbing to the heat and pressure, but it was enough. It confirmed the horrifying conditions, a surface temperature of around 475 degrees Celsius, or 900 degrees Fahrenheit, and an atmospheric pressure 92 times that of Earth's. The dream of a lush, jungle world was officially dead. But what did it look like? The first images came from Venera 9 in 1975. The world gathered to see the first ever photograph from the surface of Venus. What it revealed was a stark, alien landscape. It wasn't a swamp. It was a rocky, desolate desert under a hazy, orange-yellow sky. The pictures showed sharp, uneroded rocks, suggesting a geologically young surface with little wind or water erosion at ground level. It was a stunning, if terrifying, glimpse into another world. Subsequent Venera missions sent back more images, some in color, painting a picture of a volcanic plain bathed in an oppressive, orange glow. For years, these Soviet images were all we had. They were groundbreaking, but they were just tiny snapshots of a vast, unseen world. The problem remained, the clouds. How could we map an entire planet that we couldn't see? The answer came not from visible light, but from a different part of the electromagnetic spectrum. Just as a doctor uses an X-ray to see bones through skin, scientists realized they could use radar to peer through Venus's thick cloud cover. In the early 1990s, NASA's Magellan spacecraft arrived at Venus. Its mission wasn't to land, but to orbit and map. Over 4 years, Magellan used its powerful radar to systematically scan over 98% of the planet's surface, creating a detailed, high-resolution global map for the first time. The results were spectacular. We finally saw the true face of Venus. The Magellan data revealed a world dominated by volcanism. Thousands upon thousands of volcanoes dot the landscape, far more than on Earth. We saw vast lava plains stretching for hundreds of miles, created by massive floods of molten rock. There are strange volcanic features unique to Venus, like pancake domes, which are flat-topped circular volcanic constructs, likely formed by thick sluggish lava, and coronae, circular crown-like structures that are thought to be caused by upwellings of hot material from deep inside the planet. Unlike Earth, Venus doesn't appear to have plate tectonics, the process that drives continental drift and recycles our planet's crust. On Earth, the crust is broken into massive plates that jostle and grind against each other, causing earthquakes and creating mountain ranges. Venus's crust seems to be a single, solid lid. So how does it release its internal heat? The prevailing theory is that heat builds up over hundreds of millions of years until it triggers catastrophic, planet-wide volcanic eruptions that resurface the entire globe in a geologically short amount of time. It's a violent, cyclical process, completely alien to our own world's more steady geology. So, we had the radar maps of the ground, but what about those clouds? What are they made of? Modern spacecraft, equipped with advanced sensors, have given us an unprecedented look into Venus's toxic atmosphere. A key player in this recent exploration has been JAXA, the Japanese Aerospace Exploration Agency, and their spacecraft Akatsuki, also known as the Venus Climate Orbiter. Akatsuki's mission is to study the dynamics of the atmosphere, to understand how this hellish world works. Using infrared sensors, Akatsuki can peer through different layers of the cloud deck and track their movement. It has revealed a super-rotating atmosphere, where the winds whip around the planet at speeds of over 360 kilometers per hour, 224 miles per hour at the cloud tops, much faster than the planet itself rotates. Imagine a day on Venus lasting longer than its year, yet the clouds circumnavigate the globe in just 4 Earth days. Akatsuki has also helped us better understand the composition. The atmosphere is about 96.5% carbon dioxide, a potent greenhouse gas. And those thick, yellow-white clouds, they aren't made of water vapor like Earth's clouds. They are made primarily of droplets of sulfuric acid. Yes, acid rain is a permanent weather feature on Venus. This overwhelming blanket of carbon dioxide is the key to understanding Venus's extreme heat. It has created a runaway greenhouse effect. On Earth, our atmosphere traps some of the sun's heat, which keeps our planet warm enough for life. But on Venus, the superdense CO2 atmosphere has trapped so much heat that the surface has been baked to its current infernal temperature. It's a cautionary tale written on a planetary scale. It shows what can happen when a greenhouse effect spirals out of control. So, let's put it all together. What would it be like to stand on the surface of Venus? First, you'd be instantly crushed by the immense pressure, equivalent to being nearly a kilometer deep in the ocean. If you somehow survived that, you'd be cooked by the lead melting temperatures. The air you'd try to breathe is a toxic soup of carbon dioxide. The sky above wouldn't be blue, but a dim, oppressive orange-yellow, due to the way the thick atmosphere scatters sunlight. You would see a desolate landscape of sharp, volcanic rocks and vast, dusty plains stretching to the horizon. There'd be no blue sky, no water, no plants, no life, just the silent, crushing, searing reality of a world that took a drastically different path from our own. Venus is no longer Earth's beautiful sister. It's more like our terrifying twin, a vision of a paradise lost. By studying it, we learn not just about the formation and evolution of other planets, but we also gain a profound perspective on our own. The delicate balance that makes Earth a haven for life, our atmosphere, our water, our magnetic field, our plate tectonics, becomes starkly apparent when contrasted with the hellscape of Venus. The exploration of Venus has stripped away the myths and revealed a world more hostile and more fascinating than we ever imagined. It reminds us just how precious and potentially fragile our own blue marble really is. Thank you so much for joining me on this journey to the surface of Venus. It's a pretty wild place, isn't it? If you enjoyed this deep dive into our solar system, please hit that like button and consider subscribing to the channel. We have so many more cosmic mysteries to explore together. Let me know in the comments what planet you'd like to visit next. See you in the next video.